morning, students. Welcome back to science class on the chapter sound. In the previous class, we had discussed the characteristics of a sound wave. Okay, so first we had discussed wavelength. So what is wavelength? Wavelength means the distance between two successive crests or troughs, or the distance between two successive compressions or rarefactions is called wavelength. Okay, and we use a lambda Greek letter to represent wavelength. Then the SI unit of wavelength is meter. Okay, so then we are discussing the frequency. So frequency means what? The number of times the particle vibrates in a given time. Okay, so to calculate the frequency, we know the formula. So mu means frequency is equals to 1 by t. T means time period. Okay, next. Mm, Next, we discussed amplitude. Okay, amplitude means the maximum displacement, of the particle from its mean position. Okay, so we call that as amplitude. Okay, so today we'll discuss more. Okay, why we can hear different kinds of sound, why all the sounds are not equal, why some sounds are pleasant and some sounds are unpleasant. Okay, see, first one, the quality or timbre. Okay, the quality or timbre of a sound is that characteristic which enables us to distinguish one sound from another having the same pitch and loudness. Okay, see here we can hear many sounds at a time. Okay, so the quality of those sounds, using that quality of the sounds, we can easily differentiate. Okay, we can easily differentiate the sounds. Next, see, if the sound is very pleasant, okay, then we can say that that sound is a rich quality. Okay, if the sound is not pleasant, if the sound is unpleasant, then we can say that it is a lower quality, means that it is not a rich quality. Okay. Next, for example, if one sound it has a single frequency, this means single wavelength. Okay, so we call that as tone. Okay, so tone means what? A sound of a single frequency is called tone. Next, the sound which is produced due to a mixture of several frequencies is called the note and is pleasant to listen. Okay, see, the sound which is produced due to a mixture of several frequencies. Okay, for example, while you are listening a song, you can listen the song from the singer, then the guitar, violin, etc., then the bass sound, etc. You can hear all the sounds at a time. Okay, because those sounds are different frequencies. Okay, so it means it is a mixture of several frequencies. So that is a mixture of several frequencies is called note. Okay, so noise is unpleasant to hear, music is pleasant to hear, and soft rich quality. Okay, noise which is unpleasant. Okay, so next we will move to the speed of sound. Speed of sound. If you want to calculate the speed of sound, okay, to calculate the speed, we know the formula, that is speed v equal to, okay, v means what? Speed v equal to distance by time. Okay, so now to calculate the speed of sound, we should measure the distance and lambda. Okay, so here distance, already know the distance means we use lambda. Okay, lambda means wavelength divided by time. Right? Okay, this is distance from peak to peak. This distance is called lambda, right? So that's why we'll write speed of sound v equal to lambda by t. T means what? Time period. Okay, so better we can use capital letter. Okay, next, next we know, see here in the previous class we have discussed what. Okay, this mu equal to 1 by t. Okay, so this is called a frequency. So frequency is equals to 1 by time. Okay, 1 by time period. So now just see here v equal to, we can write this as 1 by t. So just we can substitute here, right? So 1 by t equal to mu. Okay, so right here, so v equal to lambda into mu. Okay, lambda into mu. So to calculate the speed of sound, so when you multiply wavelength and frequency of that wave, okay, when you multiply wavelength and frequency, then you will get the speed of sound. Okay, so if you want to calculate the speed of sound, first you have to multiply wavelength and frequencies, then you will get the speed of sound. Okay, so this formula we use to calculate the speed of sound. To calculate the speed of sound. So now we will discuss one small problem. Let's do this one. See, and one more thing, the intensity and the speed of sound both are different. Okay, both are also, but both are different. See, I know what is the intensity of sound means. The intensity of sound means the amount of sound energy passing each second through a unit area is called the intensity of the sound. What is that? What is intensity of sound? Intensity of sound means the amount of sound energy, the amount of sound energy passing through each second, in unit area. In unit area is called intensity of sound. Okay. See, you know what is loudness? Loudness is a measure of the response of the ear to the sound. Loudness means what? When you increase the amplitude, then we can say it has more loudness. Okay, the loudness of that sound is, we can say that the loudness of that sound is more. Yeah. So question. Yes, see here. A sound wave has a frequency. A sound wave has a frequency of 2 kilohertz and wavelength 35 centimeter. How long will it take to travel 1.5 kilometer? So, how long will it take to travel 1.5 kilometer? Okay. Yes, I will give you 2 minutes time. So please find the answer for this question. See, first I'll write the given data. Right, what is the given? Here they have given frequency. So frequency is equals to 2 kilohertz. 2 kilohertz means, kilo means 1000. Okay, that is 2 into 1000. frequency mu equal to 2000 hertz. See, 2k hertz is equals to 2000 hertz. Okay, that is frequency. Next, wavelength. So wavelength, you are right, that is wavelength is 35 centimeter. 35 centimeter converted into meter, that is 0.35 meter. Okay. Next, they have given time, right? As they have given distance, right? See that distance for second case. Okay. Second case, how long will it take to travel 1.5 kilometer? Okay. So if you want to calculate, then first we should find the speed, right? So we know the formula to calculate speed. Speed of sound V is equals to lambda into frequency. Lambda into frequency. So just multiply. Lambda is 0.35 into 2000. Okay? Yes. Tell me the answer first. Yes, quick. Multiply 0.35 into 2000. The answer is 700. Okay. So the speed of sound V equal to 700 meter per second. You know, right? Speed of sound means you are measuring the speed. That is the center of speed of sound is meter per second. Okay. Next. So what is the next question? How long will it take to travel 1.5 kilometer? Okay, how long? So here you have to calculate the time. Okay. So now we got the speed, right? So speed V equal to 700 meter per second. So we need time. So you know the formula to calculate time. You know the formula, that is speed V equal to distance by time. Okay, so we need V equal to d by t, right? So we need time t equal to, we can write distance by speed. Yeah. Okay, so just substitute. What is the distance? That is 1.5. So convert it to meter. That is 1.5 into 1000 divided by speed is 700. Yes, quick. Tell me the answer first. Quick. So t equal to 1.5 into 1000 divided by 700. Quick, tell me what is the answer. Yes, so 15 by 7. So what is the answer? 15 by 7. Okay, so I'll write here t is equals to, when you multiply, you will get divided by 700. Okay, cancel. Finally, you will get will get right here. So T is equals to 15 by 7. So what is the answer? 15 by 7. So 15 by 7. Okay, that is 2.1. So 15 by 7 is equals to 2.1 seconds. So that sound, the speed of that sound, speed of sound is 700 meter per second. So to cover 1.5 kilometer, it will take 2.1 seconds. Okay, so it will take 2.1 seconds. Next one. Calculate the wavelength of a sound wave. Wavelength of a sound wave. The wavelength of a sound wave whose frequency whose frequency whose frequency is whose frequency is 220 hertz and speed is and speed is 440 meter per second in a given medium. Given medium. Okay. So here, calculate the wavelength of a sound wave whose frequency is 220 hertz and speed is 440 meter per second in a given medium. Okay. So first write the given data. No, assign you 2 minutes. Find answer for this question. Quick. First. First. Yes, no one is responding. Waiting for your answer. See, calculate the wavelength of a sound wave whose frequency is 220 hertz and speed is 440 meter per second in the given medium. Okay, calculate first. See, first write the given data. So frequency is mu equal to 220 hertz. Then speed of sound. So V is equals to 440 meter per second. Okay. So then calculate wavelength. V equal to lambda into mu. Okay. So we need lambda, right? So bring mu this side, that is V by mu equal to lambda. So then we can write lambda equal to V by mu. Okay. So what is V? Speed of sound is, that is 440 divided by 220. That is the answer. Quick. Yes, first answer is 2. Okay, what is that 2? So 0 get cancel, 20, 2 ones are 20, 2s are. So finally we will get 2 meter. Okay, wavelength means what? It is the speed, right? Sorry, wavelength means what? It is a distance. So that's why the unit of wavelength is meter. The answer is 2 meter. Okay. Yes, sir. Next move to the speed of sound different in medium. Okay. Already we know what is the medium. Okay. So medium, for example, air. If you take air, we can say air is one medium, water is one medium, and if you take glass, glass is another medium. Okay. So now we see the speed of sound in a different medium. Okay. Say for example, if you take aluminium, okay, in aluminium, the arrangement of particle is different, so we can say that that is one medium. Then if you take nickel, even nickel is also, in a nickel also the arrangement of particles, that is also different, so we'll call even that nickel is also medium. Then if you take water, okay, so water, in water also the arrangement of particles are different, so we'll consider even the water as one medium. Then if you take a petrol and diesel, milk, there also the arrangement of particles are different, so we'll consider those are also medium. Okay. Then if you take a gas, hydrogen, helium, air, oxygen, so in hydrogen, oxygen, there also the arrangement of particles are different, so we will consider those also medium. Okay. So now already you know, right? So to travel sound, it requires medium. Okay. If there is no medium, suppose if you create this room as a vacuum, then you can't hear anything, then you can't cause any kind of sound. Okay. So now my question I will ask, for example, say air and water, water, then solid. Okay, so I will pass one sound. Okay, I will pass one sound. So now out of these three, in which medium the speed of sound is maximum? In which out of these three, air, water, solid, in which medium the speed of sound is maximum? Yes, sir. Answer for my give answer for my question quick. Okay, so what is that? I will produce a sound, same kind of sound. Okay, same kind of sound. Everything is same. Frequency, everything is same. But in which medium the speed of sound is maximum? Tell me quick. Yes, somebody said air, Srishalam, air, Sangeeta, Kalkonda, solid. Okay, see here, you know, already we have seen, right? See, when you produce a sound, what will happen? The atoms present near your mouth. Okay, so they will gain energy and they will collide with neighboring atoms. Okay, so in solid, all the particles are tightly arranged close to each other. Okay, but what about water? Little bit freely. Sorry, loosely arranged. What about air? That is freely. Okay, so in a solid, more number of particles are there to travel sound. Okay, for that one, it requires medium means it requires particles or atoms. Clear? So in a solid, more atoms are there. So which means the speed of sound is maximum in solid. Okay, the speed of sound is maximum in solids. Why? Because in solids, more the particles are tightly arranged, then the speed of sound is increases. But what about air? It is a little bit less compared to solid. Why? Because in water the particles are loosely arranged. Okay, so that's why the speed of sound in water is less compared to solid. But what about air? In air, the speed of sound is less compared to water and solid. Why? Because here less number of particles are there in air, and here the particles are freely arranged. So that's why the speed of sound in air medium is less. Okay, so the speed of sound is maximum in solid. Why? Because in solid all the particles are tightly arranged. Okay, to travel sound it requires medium means it requires particles, it needs particles, right? So particles are more particles are present in solid. Why? Because in solid all the particles are or atoms are tightly arranged. So that's why the speed of sound is maximum in solid. Okay, next, here in I think you can see in a textbook. Okay, so they have given some the speeds of sound in a different medium. Okay, so in aluminum, if you talk about solids, in solids, you know, even in solids also some elements or some substances are different, right? Because suppose if you take aluminum and nickel, the element of particles are completely different. Okay, so here in aluminum. Okay, so here they have in your textbook they have given the speed of sound. Okay, the speed of sound that is at 25 degrees Celsius. At 25 degrees Celsius. Suppose I will increase the heat. I will increase the temperature, say 40 degree centimeter. At that time, do you think that the speed of sound is increases? For example, see here, just imagine this room. Okay, the room temperature of this class is 25 degree centigrade. So okay, so here I will produce a sound, and the speed of that sound is say 346 meter per second. 346 meter per second. Okay, 340 meter per second. So now I will increase the room temperature to 40 degree centimeter. Sorry, 40 degree Celsius. Okay, 40 degree Celsius. At that time, do you think that this speed increases or decreases? Okay, when you increase the room temperature, then this speed which increases. Okay, you know, when you want suppose you want rod. Okay, so when you heat this rod, what will happen? So inside inside what the atoms they vibrate rapidly, right? When you give see, when you give heat to a substance, what will happen? Which means you are adding a kinetic energy. Okay, then the particles they move very fast, and they vibrate very quickly. Why? Because you are giving the heat. So that's why when you increase the temperature, then what will happen? The particles, okay, see here, when you increase the temperature, what will happen? Then particles they will vibrate very quickly. At that time, when you produce a sound, what will happen? They will move very quickly. They will move very quickly, and they will collide with the neighboring atoms. Why? Because see, one is you are providing sound energy, and they are getting, and these atoms getting energy from the heat. Okay, so when you increase the heat at that time, the speed of sound which increases. Okay, so now in your table, context we have given that table, right? At a 25 degrees Celsius, aluminium, the speed of sound in aluminium is 6,420 meter per second. Meter per second. So which means in one, for example, you have say 10 kilometer aluminium rod, 10 kilometer aluminium rod. Okay, so 10 kilometer aluminium rod. So in 1 second, when you produce a sound in aluminium, in 1 second, it will cover 6.42 kilometer. In 1 second, it will cover. When you produce a sound within a, just imagine your friend is producing sound here. Okay, then you are standing. The distance between say this person A and person B. The distance between person A and B is just say 6.2 kilometer. Okay, so when he makes a sound in aluminium, when he produces a sound in aluminium, then the person B can listen that sound in 1 second. Okay, so this is the speed of sound in aluminium. What is the speed? That is 6.42 kilometer in 42 kilometer per second, or 6,420 meter per second, which means in 1 second it will cover 6,420 meter. Okay, then if you take a nickel, that its speed is 6040. Okay, just observe in airs. Okay, so it is the speed of sound is decreases compared to solids. They have given in water, the speed of sound in water is 1531 meter per second, which means 1.531 kilometer per second. Okay, next if you talk about gases, even in gases also, see here they have given hydrogen, helium, air. In air, that is 346 meter per second. So for example, just imagine the room temperature of this lab is 20 degrees Celsius. Okay, see these values are obtained, means the temperature of the substance should be equal to 26 degrees 25 degrees Celsius only. Okay, so now just imagine the room temperature of this lab is 25 degrees Celsius. So now I am talking here, so you can hear my voice. So here the speed of my sound, that is equal to 346 meter per second. Okay, so this is about speed of sound in different medium. Okay, so keep in your mind the speed of sound is maximum in solids and little bit less in water and gases, and the speed of sound is completely zero in vacuum. The speed of sound is completely zero in vacuum. Okay, why? Because there are no particles in a vacuum. Vacuum means what? It is an empty space. Okay, no particles are present in vacuum. Okay, to travel sound it requires some atoms, right? In vacuum there are no atoms, so that's why the speed of sound in vacuum is which is equal to zero. It can't travel in a vacuum. Suppose if you create this vacuum, see, if you just imagine you are standing in front of here only, say 10 meter, say 30 centimeter distance. If I produce a sound, then you can't hear even a single word when you create this room into a vacuum. Okay, so time is over. I will stop here, so we'll continue class tomorrow. Thank you.